anybody getting sick?
Kind of for a second.
Okay, great. So you're not.
Okay, keep going, or you're just hiding the symptoms and infecting yourself. Anyway,
I think we're good.
take vitamins, wash your hands, try to cover your mouth if you cough, and zinc. Zinc is good, maybe. I don't know. Medicine is good too, but it's not a cure-all. So if you are feeling sick, please make sure you get rest tonight. Your body needs strength. Ooh, and drink lots of water, fluids. Okay. What's tangent of u?
-3/4.
Good. Wasn't it just opposite over adjacent? So weren't you guys just supposed to plug that in? So did we get stuck or did you power through?
Oh. Well, that's why you did that.
Substitution. The tangent comes out, its opposite over adjacent goes in, right? So all it was simplifying complex fractions after figuring out, oh, I have a triangle, we needed to make it first, then we needed to pull out the opposite over adjacent. And then solve. Why does this always hate me so much? You guys reduced the 2 and the 4, right? -3/2.
That's very simple.
And you squared the -3/4 to be 9/16, right? Anybody use my cool trick to simplify? And say, hey, what would be the common denominator between 2 and 16? Could you have gotten a common denominator, put it together, divided by the fraction by multiplying by the reciprocal? Yes, and I'll show that in a second, just in case. That's what's best for you. But for the rest of you guys, I took the 2 and the 16, said, hey, what would be the common denominator? Well, 2 goes into 16. I multiply top and bottom. That's my complex fraction trick that we talked about back in section 5-2 before the Christmas break, if you don't remember. That's why. This little 16 is technically over 1, if that helps. So 2 and 16 reduces to be 8. 8 and 3 is -24. Pause. The 2 and the 16 reduces to be 1 and 8. 8 and -3 is -24. This 16 has to distribute. What's 16 times 1? Thanks, Thomas. Good morning, guys. 16 times 1. 16. And then, explains a lot. 16 times this one. 16's cancel. What do I got? -9. Dun, 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 dun. Because all I have to do is say, oh, hey, -24 and 16 minus 9 is 7. Could you have gotten there? 5. Bring it to me, it'd be -3/2 all over what?
1 minus 9/16.
Here's the other way you could have gone. This would be old school, like, I don't know, pre-algebra way. Multiply this guy. That was a bed. I'm not going to make it in, too much pressure. Okay, multiply this guy by 16/16, right? Then I could have said, hey, this is the same thing as -3/2 divided by 16 minus 9/16 would be, no, not 9, that's a struggle, 7. Basic subtraction. Anyway, 7/16, true?
True.
How do you divide by a fraction?
Multiply.
Multiply by the reciprocal. How would you keep going? Which one's easier? Your choice. Your choice. Which one's easier? Your choice. But don't be illegal. Could you have flipped this guy right now? No. You need to see this whole denominator as what's being divided. Well, this is what's being divided, and it's being divided by the denominator. This whole thing you need to make into a single fraction in order to be able to multiply by the reciprocal and solve. Both ways are good, your choice. I just don't like writing many steps, so I just do it all in one. How do we do?
We got it, this group did.
That's good.
Way to go, way to go.
How many people got stuck on how to get rid of tangent in the actual formula? Okay, yeah, that's pretty normal. Be careful. If you thought to rewrite the tangent again, that's dangerous. Remember, tangent is opposite over adjacent, so I need to substitute out the tangent of u. He comes out of the game, negative 3/4 comes in. Then we're just simplifying the fraction. How many people got stuck on the complex fraction? Interesting. Huh. Okay. Anyway, some of you might have gotten stuck if you had known how to keep going. Does it make sense now? Give me a thumbs up real quick if it's good. Or at least understand the idea. Okay. Good topic for your lunch after school. Good ask. What is all this? Oh, I know what this is. Okay.
Wait, what?
Question. So, the type, no, we already wrote them down. It's okay, you already wrote these down, right? Are these ones that you're supposed to memorize? Yes. Power reducing ones to memorize, they're in the yellow box, but we also started them yesterday. Now we're going to use them. You have the formulas at the beginning of your notes. Go straight to the example. You already wrote that down. The type of example we were just talking about was given a trig ratio. But I think we were given negative 3/5 equals sign. For those of you that understood, no stress. Write down the next example. And try to think through what type of problem is this? Those that understood the last example. Read the new one. Think of what type of problem is this? Okay, what is it? Rewrite in terms of the first power of cosine.
It's a T-proof.
What?
No.
Is it one?
Rewrite.
Cosine 2u over
You're not solving for an actual angle. You're right, you're not solving for an actual
Fine.
angle. They don't actually say prove though. So it's kind of like section 5.1 where it's like, hey, do some stuff to that, okay? It's kind of like 5.1 where they didn't really give you an end picture. It just said, go. Technically, the problem starts with not even this, which probably made you think T-proof. It started with that. Why did I show you guys the first step of making cosine to the fourth, cosine squared times cosine squared?
The power reducer.
I could plug in for both of those. All right, kiddos, start there. Plug in for both of the cosine squareds and see if you can get an expression that doesn't have a cosine to any higher power when multiplied out than 1. And if it doesn't, you have to keep going somehow.
Oh,
Go. Let me give you what sine or cosine or tangent. They're telling you what the signs are. Because we know sine is opposite over hypotenuse, I can say opposite is back up, hypotenuse is back up. So the hinge I'll use is to which is how we are. That tells us where, quadrant 4, opposite, and hypotenuse. The back of the end could let me solve for this third step by taking c squared minus b squared is a squared. We end up with a positive 4 after doing the 19. once we have that, the problem I was giving you guys being in class was go ahead and find tangent of 2 times this guy, which we've never found. We just know what he looks like as far as his triangle. We don't actually know who he is, so we can't plug that guy in. We don't know who he is. We can't use our calculator to do the inverse. Don't know who he is. But we can use the formula that says 2 tangent. This is a formula from the double angle property. It says this equals 2 tangent of theta of that guy, all over 1 minus tangent squared of theta. Which is why I had them come to the triangle and think about who is tangent. Tangent would be opposite over adjacent. So we take that and we plug in for this guy. And for that. And that's how we got this. And then we have to do all of that math to make it.
If you multiply 2 like this, it's 2 over 1.
Was it enough just to plug in for cosine squared times cosine squared? Was it enough?
No.
Because if you were to, I said, will the result, when multiplied out, give you still a cosine to the highest power of 1? If you multiply this guy out, aren't you going to have a 1/4 in the denominator? Sorry, or a 4 in the denominator?
Yeah.
Okay. And the numerator, aren't you going to have to FOIL it? So you're going to get 1 plus cosine 2u plus cosine 2u, which will be plus cosine, I apologize, I plugged in, that should be an x, not a u, right? A cosine 2x plus a cosine 2x, outer plus inner will be 2 cosine 2x. This guy is good, but what's not good?
Cosine squared.
And all of these guys were being multiplied, divided by 4, or multiplied by 4 over 1? 1/4. Who doesn't belong? Who's not allowed to stay if I'm only allowed first powers of cosine?
Cosine squared.
How do we get rid of him?
Do it again.
Yep.
What?
The 1/4 times 1, I have no problems with. He does not have cosine to a higher power. So that's okay. The 1/4 times 2 cosine 2x, that'd be 1/2 cosine 2x. I have no problems with him, because he's only a cosine to a first power. But the 1/4 times cosine squared, I do have issues with. So I need to keep the 1/4, but cosine squared 2x, I need to come back and use that formula again. My question to you is, if there's a 2x inside now, what would happen when we use the formula?
The thing we did earlier.
It'd be 1 plus what?
Cosine.
Cosine 4u 2x.
Close. Cosine 4
X.
x. Now hold on, some of you guys need to digest this just a little bit. How on earth, if the formula says 2u, did this become 4x? What's in the u spot that needs to be doubled? It was cosine squared of who? 2x. And what do I do with whoever's in there? I double them. Oh. So 2x doubled is going to be, or 2x times 2 is going to be 4x. So what if I was trying to simplify, for instance, what if I was trying to rewrite or use the formula on something like sine squared, don't worry, it's not a fourth power, don't have to do it twice anymore, sine squared of 9x. How would we rewrite that one in terms of the first power of, okay, Now sine, not cosine, I apologize.
1 minus cosine 18x.
1 minus, I can keep it cosine. 1 minus cosine of double the argument. Well, what's the double of 9x? 18x. And that would be 1. That one was done up there. We could simplify it and write it nicer, whatever, but if it's sine squared of 9x, I just want to make sure you guys know the formulas work in the sense of whatever is inside sine squared or cosine squared or tangent squared, when it comes over to the formula, it just needs to get doubled. So the 2x became a 4x, the 9x became an 18x, double whatever is currently in the sine or cosine or tangent squared. Does that make sense, kind of? Some of you might have just thought, oh, it's always 2 times x or 2 times theta or 2 times, well, no, it's double whatever was the original argument. All right, that was a little weird, a little tricky. Let's do something a little more, let's not do that one. We just did sine squared of 9x. Let's not do a sine to the 4th. Can we use a half angle? Wait, did I say you guys had to memorize half angle?
No.
Ah, what did I say though?
Bonus.
You could. It'll probably show up as a bonus. So let's go ahead and I'll mark it with a B. But let's still use it. So example, here we go. Let's still use it. But you might want to, next to these formulas, you might want to write yourself a little note. We didn't get to write this down when we did it quickly at the beginning. So you guys wrote down the formula. Pause, pause, pause. Go find where you wrote this down. Go find where you wrote this down. In the beginning of 5.5, write this note right next to these formulas where you wrote them, okay? Because the struggle is all of these formulas, or at least the square root ones, so the half angle of sine and the half angle of cosine. Do you see this little plus minus? Does that mean the answer is both at the same time? Look at the note. It says you gotta choose the right one. You gotta choose the right sign based on the information that's given to us. You have to choose the right sign based on the information given to us, because in one specific quadrant, sine or cosine will either be positive or negative. So the formula says, you know what, as a formula, I can't tell you which one. You're going to have to use your own knowledge of trig functions in the unit circle to answer it yourself. That's what the plus minus is for. You have to figure out which one's the right one. Okay, once you get the note written, should be close. Once you get the note written, should be close. The example says find the exact value, right? Do you think a rounded decimal is appropriate for an exact value?
No.
Oh, it's an approximate. So this is saying, hey, this is a unit circle thing, guys, or it's something you can do or solve by the unit circle. But why is that a struggle? Where's
Right.
105? Second quadrant. Where is the second quadrant? Closer to the 90 or closer to the 180?
Closer to the
Okay, how far away from 90?
13 degrees.
That has a 75 reference angle? We didn't do 75. We did 30s, 45s, 60s. How do we do a 75? Nothing in geometry. There was never a 75. What would that be? 75, 15, 90? That wasn't a special thing. So how is it possible? Because 105 is half of doubling. Who is the half of?
210.
Is 210 a unit circle value? That's 180 plus 30. So how are we going to solve sine of 105? We're going to say, oh, that's the same thing as sine of the half angle plus of 210, and then we're going to come up to this formula and say, okay, u is equal to 210. Let's solve, solve, solve. The plus or minus, I'm in a circle because we need to choose that. I'm going to put a little question mark. Plus or minus, we have to choose that when we're done. square root of 1 minus cosine of 105? No, we don't know it.
210.
Cosine of, exactly, the 210, which we do know. All over 2. Now, to be honest, the half angle formula really only helps us with 22.5 angles, half of 45. Or 15 degree or 75 degree angles, half of 30 or half of 60. So it still doesn't allow us to do the exact values for every single possible trig out there, but it does let us do more than we could have otherwise. Has anybody thought about 210 yet?
Yes.
He's in the third quadrant, right?
He's over a lot, down a little.
Yeah. He's a 30 degree, which visual people over a lot, so cosine is negative root 3 over 2. Down a little, so sine is negative 1/2. Over a lot, down a little.
Since we're subtracting, it's
Andrew's already seen, since we're subtracting that cosine is the negative root 3 over 2. Subtracting a negative is going to be an addition. So when we go to plug in, it will be the square root of 1 plus root 3 over 2. We do have a complex fraction. Some of you might want to do a common denominator up front and then divide by 2 over 1, which is multiply by 1 over 2. Some of you might not mind my trick of seeing that little innermost denominator and multiplying top and bottom by him. And some of you, if you're wondering about the legality of this, I'm doing that under the square root. Still totally legal, multiplying by 1, but doing it under the square root. Others of you might be doing common denominators, that's okay. We end up with 2 times 1 is 2. The 2's cancel. Rad 3. All over 2 times 2 is 4. I can't really simplify this, guys. I don't know what that is. It's going to be a nasty decimal. But what can I do if there's a 4 in a denominator under a square root? I can make it a 2 without the square root. Good. I can make it a 2 without a square root. But we still have that dilemma of needing to choose plus or minus. So now we have the final numeric representation. Square root's only up top. It's the only one that I can't simplify. Square root's out of the bottom because I took it. Square root of 4 is 2. So is it plus or is it minus, and why? In the third quadrant where 210 is, sine would be a negative, but what am I actually finding?
cosine.
Well, I'm using cosine from the third quadrant, which is also a negative, but what am I finding? Yeah, sine of 105, and guys, what quadrant is 105 in?
Second quadrant.
Yeah.
Positive.
So what sign is second quadrant? Positive. So even though I'm using 210 for my purposes, half angle formula to solve for the numeric answer, I'm actually finding the sign of 105, which is in the second quadrant, which is why I will establish this as a positive. I'm just showing you, writing the positive because that's me choosing and not just ignoring. But normally we wouldn't write the positive, we just leave it off and it's assumed to be positive. So be aware, when you're doing the half angle, it does say plus or minus, but that cannot be the answer. It must be one or the other if they've given you some sort of specific clue. And so use what quadrant the answer is in, the final answer, not the in-between steps. And that establishes the sign of the sine, or the cosine, or the tangent. But that establishes the sign. Okay, I think we're close. We just used the half angle property, right? Or properties. Ooh, pause. We're not going to do the whole thing. Pause. We're not going to do the whole thing. But question, what type of problem is this? The directions won't necessarily get you there. What type of problem is this?
We were going to draw a
Triangle. It's like that one up there that we did at the beginning of class. Well, we finished it, kind of, at the beginning of class. It's very similar. It gives us a trig, gives us a fraction. We need to make a triangle. So guys, how are we going to make a triangle? Draw it because tangent, SOHCAHTOA.
Opposite over adjacent.
So I have my opposite over adjacent. Where's my triangle going for you? What quadrant? 3 pi over 2 to 2 pi? Fourth quadrant,
That's what this is.
Yeah.
which is why we're going over here, and we're going right here, and opposite, adjacent. And then some of you know Pythagorean theorem, so then when we do a squared plus b squared, 144 and 25 is 169, square rooted is 13. Be careful. If it was in a different quadrant, the 12 might have been negative and the 5 might have been positive, making the whole thing negative. I had to make sure that my opposite was the negative one, which is true in the fourth quadrant. The adjacent was the positive, which is true. But if I was in like the second quadrant, the signs would have been switched. This is U's triangle, right? Okay. So let's just choose one. Let's just choose, I don't know, sine again? Let's just choose sine. They want us to do all of them, but we don't have time for that. What's the formula for the half angle of sine again? You guys have it remembered. Plus or minus. Wait, pause. We gotta choose that, right? Square root of, sorry, keep going.
1 minus cosine u over 2 over 2.
Okay. So, what can I plug into that formula?
Cosine u.
Yeah. Cosine of u says, look at u's triangle. There he is. Take the cosine. SOHCAHTOA. What's my adjacent over hypotenuse?
12 over 15.
Does anybody like my trick yet? Is anybody gonna do it?
No?
Okay, so for those of you guys who don't like it, get a common denominator and then multiply by the reciprocal. But for those of you that want to try my trick, who's messing it all up?
13.
So you multiply by 13 over 13 under the square root. When I distribute, I would get 13 minus 12 all over 13 times 2 is 26. Uh-oh, I can't square root him. Oh well. Might not be a pretty answer, but it will be an answer. 13 minus 12 is just a simple 1, right? 13 minus 12. Because the 13's cancel on that guy, but it doesn't cancel on that guy.
But if you don't do it that way, we should do 13. That's what I got.
Mm-mm.
Because if it's 13 over 13 minus
2 over 1, reciprocal is 1 over 2, which would be 1 over 26. Because 13 over 13 minus 12 over 13 is 1 over 13, over 2 over 1, gotta flip it, that's the key. Not only common denominators, but also flipping that denominator. We can't do the square root of 26, guys, but we could do the square root of 1 if we really want to. We could have just made this 1 over root 26, because we knew the square root of 1. Some of you would make that pretty and make it rationalized. Multiply top and bottom by square root 26, you would get root 26 over 26. We still have to choose the sign though. My question to you is, are we looking in the fourth quadrant for the sign of u over 2? Who said no and why? Okay, I heard one back there. You said or Kevin?
It was John.
John? Do you have any idea why no?
No.
Okay. I agree with the no. Does anybody have a reason why we wouldn't be looking at this guy for that guy's sign?
Looking for the U.
This is u.
Double.
Who are we actually looking for though?
U over 2. Because the sign is not positive in that.
Your right sign wouldn't be positive in this quadrant, but we're not even looking at quadrant 4. That's u. We need to cut u's in half. But who is u? I don't know. Do you know? No. That's his triangle, but who's the angle? Something between 270 and 360. So pick something in between 270 and 360. 300, cut it in half, 150, a quadrant.
That's good.
What if that's true for all of them? We picked 300. Let's pick something farther away from that. How about 355? 354. Cut him in half. 170. 2. Second quadrant still. 360 cut in half, and you can't even have 360. That's 180. It won't go past 180 because there won't be an angle bigger than 360 in this quadrant. So guess what? All the fourth quadrant angles cut in half, subtracting 180 would end up in what quadrant? It will end up in the second. Any angle written here, half of it will be over there. Any angle written here, half of it will be over here. So hey, what's the sign? Positive or negative in the second quadrant for sign? Positive. Therefore, I choose positive root 26 over 26, because for this one would be in quadrant 2. That's the 2, not a, I don't know what that looks like. Okay, we've been practicing half angle, and I gave you this example just because he made you struggle with the plus or minus when there's not a number given. Last ones. Let's go to this one. No, we have time. We can do both, I think. I know, I just gave you lots of T-proofs in case we had time. All right. I apologize for the flipping back and forth. Here we go. You guys have the product to sum formulas written down in your notes that you can reference? Product to sum. As you guys are writing this, let me just kind of give you a hint as to why you're looking at these specific formulas. It's sine of somebody times product, sine of somebody times cosine of somebody else. It's sine of somebody times cosine of somebody else. Sine of somebody times cosine of somebody else. Now here's one of the reasons I'm not having you guys memorize this formula. I have no clue, besides the fact that there's like a plus or a minus somewhere in it. I have no clue what this formula is. It's so rare to see in other math and higher math and other applications that you could always just look it up. It's so rare to see you could look it up. Kind of like, I don't know, area of trapezoid? No, area of a pentagon. There you go. How often do you see that one? Look it up. I'm sure there's a formula somewhere, right? Same thing here. So let's not spend all this time memorizing a formula. Let's just see if we can use it. Kiddos, what is the formula for sine of u cosine of v?
Bracket. So sine of u plus v
Plus sine of u minus v.
This is kind of awkward, right?
Yes.
Just see if we can use it. There's a u, there's a v. Let's go. 1/2. Big old bracket. Sine of. All right. Let's see if we can make this easier. This guy plus that guy. See if we can do it. Plus, the addition doesn't change any signs. What would x plus x be?
2x.
2x. What would y plus a negative y be? Nice.
Now we subtract.
If it helps, you can always do over here, what's u plus v? X plus y plus x minus y. Distribute the plus, everything stays the same, 2x minus 0. But we also need u minus v, right?
2y.
What's going to happen when I subtract?
X cancels out.
X's cancel, y minus a negative y will be 2y. That's my final answer. Well, I guess you could write it different ways, but it'd be 1/2 sine of 2x plus 1/2 sine of 2y. It says change from something or two trait expressions that were being multiplied to two trait expressions being added or subtracted. Oh, check. Addition, done. Product to sum. Multiplication to addition. Ryan.
Why is there just like a 1/2 front?
Formula.
Like what is this?
Product to sum formulas, if you look at the very beginning of 5.5. Now, if you're asking for the proof behind the formula, I doubt our book gives the entire proof. I'm sure you could Google it and ask for the proof. I'm sure there is a geometric visualization for it. But since our focus is just can we work with the formulas, we're not going into that much depth. Because it's not a huge topic for you to really take from pre-cal. We're kind of just introducing further concepts and seeing if we can actually be skilled in solving. Does that make sense? Yeah, but there's definitely a geometric proof online. Okay, last one, I think, finally. Have we reached the end? Did I not put them in? Okay, if you want to put them in your notes in order to have them to look at, you can, but if you want to just say whatever, this is the very end, we don't have to memorize them anyway, we don't. You can take a picture of them, or you can just look in your book and be like, oh, those are the formulas I didn't write down. I apologize, because right now to put them in your notes, they're going to be awkwardly apart from the others. You might just want to take a picture. Sum to product. Do you guys see how we're starting with an addition or subtraction? And just going backwards to the sine, cosine, cosine, sine. Cosine, cosine, sine, sine. We could go through and memorize them, but we're not going to. Once again, they're so rare that if you do ever need them, you'll look them up, and if you need to memorize them, then you will. But we do the same thing of looking at identifying a U, identifying a V, identifying which pattern or what or how we've been given the information as to which one to plug into. We just add the two together, then cut in half, or subtract the two together, cut in half. It's just a plug and shove. So when we get to something like this, and it says find all solutions, get to something like this, and it says find all solutions. T-proof? No. No. Well, how do I get anything alone? Any ideas? There is a property for that one, but the only property that's going to work is the one that says, oh, stink, these are separated by subtraction. I wish there was a way to put these together into more like multiplication. Pause. That's the one that we just looked at. We can take a sum and we can make it a product. Here's the reason why. Ready? Do you guys see we can add the 1 to the other side?
Yeah.
Okay. If we add the 1 to the other side question, what can we do with this guy's denominator? When we add 1, that's done. When we add 1. What can we do with this? Multiply it to the other side. How do we get x alone? I stink. How do we get anything alone? There is a sum to product formula. If you want, you could write it down right now, because you guys don't have those ones. Where we have sine of u plus, nope, minus, sine of v. You guys need to have your formulas close in this section. Because you're not even supposed to memorize them all. Have your formulas close. Wait, that's like the test. Part 2 on Friday, when you're going to have what in front of you that I'm going to give to you? All the formulas that you get to look at and reference to do the problems. So my person that said how I'm going to do this test, looking at formulas hopefully and applying what you've learned. Okay, so we have a sine minus a sine. This guy is the guy to use. 2 cosine, average the u and v, times sine, subtract the u and v and divide by 2. So 2 cosine, add them, divide by 2. Sine, subtract them, divide by 2. Alright, so we can change this to b. I wonder if this will help. Here's my u. Here's my v. 2 cosine, add them. What's 3x plus 1x? 4x divided by 2. So 4x divided by 2 is
2x.
nice. Times sine, subtract them. What's 3x minus x? 2x. Divided by 2, 1x. Does this help at all?
Yes.
No addition, or I should say no more subtraction. Everything's being multiplied. And I now have some common terms. The proper way to solve this one would be to subtract the cosine 2x from both sides. It'd actually be easier for some of you to see if I write it next to the expression. 0 equals, can't I pull out a common? Cosine 2x? And get 2 sine x minus 1. What do I do once I factor? Set each one equal to 0. When will 2 sine x minus 1 equal 0?
0.
Careful, that's when sine x equals 1/2. That's not going to happen at 0.
Oh.
I think you might have been thinking this one. When is
Yeah,
cosine
2.
2x equals 0? We're going between negative pi and pi, so up 180, down 180. Sine is positive first, second quadrant, which will both happen on the way to pi, or 180. At each of the pi over 6's, so pi over 6 and 5 pi over 6. When will cosine be 0, though? Starts at 0, cosine's 1, pi over 2. And 3 pi over 2. And negative pi over 2. Why am I doing these ones that are outside of our range? Why am I looking for 4 going positive too far and negative too far? Do you remember what we have to do? When you cut everybody in half, when you multiply everybody by 1/2. Now they're fourths and now they fit. So you would end up with x equals plus or minus pi over 2 times 2, 4, and plus or minus 3 pi over 2 times 2. Okay, this is a very packed section. What do you guys need in order to be able to get through section 5.5? The formula's nearby. The formula's nearby. Some problems are going to tell you exactly what formula to use. Look it up and say, all right, can I use a formula? Is it a life skill to be given some sort of procedure, some sort of rule, some sort of task, some sort of direction, and be able to follow it? Sadly, yeah. Let's see if you can follow the formulas tonight. Come tomorrow, we're going to go over 5.4. We're going to go over 5.5. You need to be studying formulas that you need to memorize, which are not all of them. Bye, guys.
You guys cut it already.
You know what?
It's kind of troll.
You need to know about the clay and how it's.
Yeah, because I was thinking something like this, how before we have like 2 or something, and when you separate them, it'd be like sine of 2x plus sine of 2.
Oh, sine, cosine, cosine.
Yeah, like that. How you can set, like,
Oh,
when you
that was
expand. Yeah, I want to
You can't distribute sin. Those were the formulas.
Oh, okay.
That was what we couldn't do.
Yeah.
We'd have to use our spiffy formulas.
Okay.
And then it'll match
That's what I
up.
was wondering. Like, can we expand it? Like, 'cause before.
I wish, right? Wouldn't that be so much faster? But it's illegal. And we tried to do an example and we're like, oh yeah, it doesn't work at all.
Yeah.